Back with example 2. If $7,500 is invested at 9% compounded monthly, the future value of the investment S after X years is given by that function. And so again, S is going to be the future value of the investment. X is going to be the number of years. Don't worry, you'll get lots of practice with these new variables and stuff as we move into chapter 6 out of chapter 5. The big thing for me today is that we just kind of get accustomed to this a little bit. And if you were using GeoGebra on the last one, recall that you can just click that to turn those things off and use the new input. Or you could come up here and say, I want a new thing in GeoGebra and just say don't save. If you do that, it will bring your scale back to being here. So recall that you can hold down Shift and change one scale at a time. You'll notice the y-axis is changing. The x-axis is not when I do that. And if I hold down Shift and come over here, the x-axis is changing, the y-axis is not. So we will use that to help us find our graph after we graph it here in GeoGebra. So again, I'm going to use this as an opportunity to sort of just talk through what happens to these things as time goes on. I just copied and pasted from the presentation. And oops, I don't want to point. So I'll turn that off. I want to move. Still have my point tool on. So we want to hold down Shift and just pull this axis down until we find our graph. There's our graph. And so I'll pull it over and maybe look at it over 20 years. Again, you'll notice here it has this level of steepness, and out here it is more steep. So moving on, because you took Math 135 with Schlegel, you decided to invest $7,500 in an account and leave it for your first grandchild to inherit when they turn 25 years old. Let's pretend that you are 20 years old right now, and you expect your first grandchild to turn 25 when you are 65. And so that's in 45 years. How much would your grandchild inherit? So I'm going to use the GeoGebra thing here. We're going to actually answer the question with Wolfram, but just to see a picture of what's happening to the gift that you gave this grandchild. You'll see again here in the beginning, it's not growing super fast. From 0 to 5, it's going up maybe a half of a box. From 5 to 10, it's going up definitely a full box. From 10 to 15, it's going up almost probably about 2.5 boxes. And so we have to actually zoom further down to get to the place where we would see what would happen to this investment when it reaches an age of 65 years old. So it turns 65. When you turn 65, the investment will be 45 years old. So we only need to see over to 45. So if I were to grab a point, and again, we're going to find the exact answer using Wolfram, this $7,500 is going to turn into about $427,000. It's probably going to be more like $425,000. So you would be literally able to give your grandchild the gift of nearly $500,000 by putting $7,500 away today or at the day of their birth and forcing them to leave it in their account until they turn 25 years old. Again, this is how rich people stay rich, and why this whole thing of generational money is such a big deal, because you can literally pass wealth, huge wealth, onto future generations without huge money to start with. So going to Wolfram to find the exact answer here. Again, that was more of a demonstration in GeoGebra just to show what's going to happen with the problem or the graph than anything else. And so we need to put in here, how many years after was it? It was 45 years later. So we put $7,000 away. We left it there for 45 years and then gave it to our grandchild. I'll write the math down. I'm actually going to pause while I write the math down, so I'm not wasting your time. So I took a moment to write the math down on my iPad and that, and what we end up with is, here's what we ended up putting into Wolfram. The grandchild would receive $424,024.41. Not bad. All that the grandparents did in this situation was put $7,500 away into an account and leave it alone for a long time. Time is fertilizer for money. And so let's see where this problem takes us from here forward. So this was, what was this, part B? I hope this is interesting, everyone. I hope you're enjoying this. For part C, let's pretend that your grandchild doesn't need the money. Maybe they won the lottery and they're doing just fine. And the money, they don't need the money, and they save the investment for their child to inherit 25 years later. So now the investment is 70 years old. How much is that great grandchild of yours now going to inherit? And so, as I did a moment ago, everyone, I'll pause while I write the math down. I'm just going to be repeating the same equation. This time, instead of putting in 45 for the number of years, we're going to be putting in 70. So as we can see, everyone, I went ahead and put 70 in here. We get a weird looking number in Wolfram because the number is actually like so gigantic that Wolfram is having a hard time dealing with it. So when you see this times 10 to the 6 here, it means that this decimal needs to be moved this direction 6 places. So let's do that. 1, 2, 3, 4, 5, 6. So we will put our number down. I'm going to write it on my iPad. I'll bring my iPad up in a moment. So 8939 7.46. So we'll bring this up, everyone. I'll have a grand finale here in a second. This $7,500 was left alone in the account for 70 years. Let's take a look at how much this great-grandchild is inheriting. We'll throw our commas in there. The $7,500 turns into $3.9 million, nearly $4 million that this person would receive 70 years after the grandparent, or in this case, the great-grandparent, put the money in the account. So again, everyone, 20 years feels like a long time. If we were to look at this graph once more in GeoGebra and just be like, hey, let's make sure that this is a for real thing. Again, I can slide. If I hold shift, I can slide over to where I can see 70, and you'll see how fast it's just increasing incredibly quickly. So if we pull down, here's $4 million. We're just under that $4 million mark after 70 years, and you can see how fast it went from 60 years being about 1.6 million, it looks like, to 4 million. So time, again, is fertilizer for money. It's growing super fast over here compared to how it's growing over here. So yes, leaving money in an investment for 20 years is great. Look at where it's at. 30 is better, 40 is better, 50 is amazing, 60 is incredible, and 70 is like, oh my God. Look at how much growth it had during this 10 years right here. And if you're to play it out, everyone, and continue out to 100 years, as I mentioned, time is fertilizer for money. In 70 years, you're almost 4 million off of $7,500. In 100 years, it's 60 million. So $7,500 has the potential to turn into 60 million over time. And so again, everyone, time is fertilizer for money. So how much would we make? How much would you make for doing nothing over this period of time? Well, that's going to be a simple answer, everyone. We started with $7,500. So to make $3,989,397.46, we would subtract our original 7,500, which seems like chump change at this point, and we would have made. I'm going to need to go back and finish up part B as well, which I will do in a moment. So for part B, the grandchild would inherit, the great-grandchild would inherit $3,989,397.46. And anyway, if we subtract the measly $7,500 that we started with from that, we still have something ridiculous like $3,981,897.46. I think I did the math on that correctly. Honestly, I don't care, because look how small of a portion this $7,500 that we thought was a lot starting with is worth now 70 years later. Time is fertilizer for money, everybody.